Welcome to this short presentation on an initiative led by ocean farmers to develop local strains of seaweed for community farming. To give a brief overview, seaweed farming in Madagascar started in the 90s, limited to Capophycus and Euchema species. Today, a network of private seaweed farming companies exist, producing 3,500 metric tonne of dry seaweed a year for the Carrageenan market across 5 regions in the southwest and northeast. Production is relying on strains originated from the Philippines, mostly Capophycus alvarezi variety Tambalang. The companies in this network engage in production from the ground level to the end client, implementing a holistic farming model focusing on positive socioeconomic and environmental impacts and sustainability. This takes place in partnership with coastal communities, conservation NGOs, national administration, and international donors. Ocean Farmers is experiencing a number of challenges related to the lack of genetic diversity in the currently farmed non-native Tambalang strain. This includes crops being highly vulnerable to epiphytes, other pathogens, at risk of widespread mortality in the face of climatic events, and plants being unable to adapt to seasonal variations in farming areas. But luckily, Madagascar is home to a high diversity of macroalgae, in particular euchematoid species. This has opened an opportunity to carry out fundamental work to catalogue, start biobanking, and developing native strains for commercial community culture. These strains are expected to be more resilient and better adapted to local conditions while remaining commercially interesting. Increasing pressures on wild populations of euchematoids due to changing climatic conditions and unregulated wild collection means biodiversity assessment, improved understanding of the role of seaweeds, and their conservation have become more crucial than ever. Fundamental studies of seaweeds in Madagascar are scarce, so ocean farmers and partners have started this early work, recognizing the importance to continue building capacity for biobanking to protect and sustainably develop coastal communities' natural capital. A pilot seed bank and hatchery was established in the southwest of Madagascar. Infrastructure includes an ambient hatchery area containing aquariums with pump flow-through seawater supply. There's a basic laboratory for spore and germline culture and an indoor nursery for juvenile culture and maintaining strains. An off-grid solar PV system and battery provide electricity for aeration of culture vessels and cooling and heating of indoor areas. There's also a backup diesel generator in case of power failure. The hatchery became operational in mid-2022, and we are pleased to host our research partner, Dr. Michael Willeda from the University of Philippines, to help define early protocols and train technical staff on field and lab techniques. During that first year, we also developed a better understanding of the timeframes and equipment required for each phase of our program. A classic plant breeding approach was taken for our work with Capophycus, which was made slightly more complex due to the triastic life cycle and novel techniques employed. A series of steps were carried out in the field, laboratory, hatchery, and sea-based test site. Extensive fieldwork was conducted to identify wild populations and collection of fertile material. Plants were brought to the lab for barcoding and cataloguing, and sporulation was induced from fertile material. Subsequently, spores were cultured to germling, juvenile, and adult stages, with basic analysis of growth data. The continuously running project has built a solid foundation on the back of promising results, which is now supported by private bridging finance until further dedicated funding is secured. Results include growth of F1 generations under ambient hatchery conditions, and the highest performing cultivars have been outplanted at sea for performance testing. Maturation of F1 generation has been observed under hatchery conditions, and there's efforts underway to achieve F2 through a process of sexual reproduction. 6 locations were sampled in the southwest of Madagascar, with results indicating genetically diverse populations and potentially new species are present. A dedicated team of local field and hatchery staff have been trained, and Ocean Farmers really realizes the requirement to include local academic institutions and the government as active partners in this project. This certainly requires dedicated funding. Alongside its core activities as a producer, Ocean Farmers contributes industry information and knowledge during technical working groups led by the Government of Madagascar. This is to develop an inclusive biosecurity policy ensuring sustainability of the sector and positive environmental, social and economic benefits are realised. It's been agreed not to import any new foreign genetic material. Therefore, the government of Madagascar recognises the need to develop local native strains of Capophycus to reduce risks from climate change and improve biosecurity. Based on this, a network of seed banks has been included in the National Aquaculture Strategy. Ocean farmers will continue this flagship initiative in the Western Indian Ocean and will share information and experiences for the benefit of all. Finally, we're grateful to all our network partners and look forward to the journey ahead in this programme.